I'm Anil Kumar, and in this video we will try to understand what is time period in radians for trigonometric functions. So we are considering mainly the primary trigonometric function, which are, let's say, sine theta, cos theta, and let me write tan theta on the other side. Now that is one part, and second we will be considering a standard form of transformed trigonometric function, which you could write as y equals to a times sine of k x minus p plus q, right? When we are talking about sine and cosine or tan. So this could be sine, cosine or tan. So that is a standard transformed form of equation which we will be considering for this particular video. Now, the very first question to you is, what is the time period of sine wave? What is the time period of cosine function? And what is the time period of tan function? Can you tell me that? Well, the time period, as you know, for a sine function is 2 pi in radians. As this is the time period I'm writing, right? Time period. For cosine, it is again 2 pi, and for tan, it is only pi. Remember that part. It's kind of very critical and important, and that's why I've taken this up. So to begin with, the time period of a sine wave in general, when I write y equals to sine theta, will be 2 pi. For cosine, it is 2 pi, but for tan, it is pi radians, right? Now, in general, if I am sketching sine wave, it will be kind of like this. A cosine wave, on the other hand, will be kind of like this. A tan wave will be kind of like this. Okay, I think without x's it doesn't make much sense. So let me add the x's here. Okay, so let's add the x's, and that's how it is. Let's draw like this. One wave I've drawn. Okay, when I've drawn one wave, now when I say 2 pi is the time period, that means it repeats after 2 pi, correct? So it repeats after 2 pi, and here, well, that is the x-axis. It repeats after pi. So normally we write minus pi by 2 and pi by 2. So this function repeats after every pi. You can see clearly, right? That is what we mean by saying that the time period is 2 pi for sine and cosine. However, it is pi for tan. Okay. So even if we are considering the reciprocal of these functions, reciprocal of sine will be cosecant function, right? Cosecant theta. For cos theta, it is going to be secant theta. For tan, it will be cotangent, right? But the time periods are going to be as mentioned here. So for the basic functions, that is what the time period is. Now what I will do is that I'll give you a few more equations. You need to write time period for those equations. Let us say we have sine of 2 theta. Then what is the time period for this? So let me make two columns here. Okay, let me use a different ink. Okay, so what you need to do is you need to write down, these are my functions. Let us say this is f of x. Now here you need to write time period. Now if you consider this equation, then time period t is equals to 2 pi by k. That should help you to write time period for all these, correct? So let me just list few functions randomly. So we have cos of 3 theta, tan of, let us say, half theta, and cot of, let us say, 4 theta, and cosecant, let me write 1 over 3 theta. So can you write quickly the time periods for all these functions? Now 2 means here there will be 2 sine waves in 2 pi. That's what it means, right? So it means the time period will be 2 pi divided by 2. So in this case the time period will be pi. In this case it will be 2 pi divided by 3. In this case it will be, pi is normal, right? pi is normal. So in this particular case, let me write down the equation separately here. So when we say about tan, we'll consider a tan, let us say kx for the time being. In that case, the time period is equals to pi by k, not 2 pi by k for tan, okay? So here for tan, it will be pi by half, right? That is 2 pi. In this case, let me get back to the normal. Cotangent is actually reciprocal of tan, so that will also have time period of pi, but 4 means divided by 4, correct? Cosecant is reciprocal of sine, so we are talking about one wave 2 pi, and that gets multiplied by 3. So that gets multiplied by 3, so we get 6 pi as the time period for this particular wave. I hope that makes some sense for you, right? So that is one way of looking into time period, especially when you're given an equation. You can quickly find the time period. The other way of finding time period is if I give you a graph. For example, if this is my graph. Okay, now, well, let me write something on the axis and then we'll figure out what is the time period. Now, let us say in this graph, I write some numbers. So this is 0 to start with, and this is my one full wave, and I write a number 10 here. So obviously, this becomes 20. Can you write time period for this wave? So that's an exercise for you. Meanwhile, I will sketch another wave for you, which will be a cosine wave, since I'm starting with maximum, right? Let's say this is cosine wave. Okay, now I want to start without any shift in horizontal and vertical, kind of like this, okay. Now in this case, if I say that this one wave here is completed at, let us say, what should I write? Let's say pi, okay. And here we have 2 pi, and then we have 3 pi. Can you write down time period for these waves? Okay, let's work it out. Time period is very clear. Time period is one wave takes 10, so it is 10 units. So here time period t is equals to 10, you see, since the wave takes 10. In this particular case, the time period is between two maximums, which is pi. So I'll write t equals to pi, correct? So whenever you are given a wave, what you can also do is, you can see when it repeats. You can either check the maximums and the distance between them, right, as we saw from the cosine wave, or you can see in a sine wave as it repeats, correct? However, if I give you a wave which is just having one minimum and one maximum, kind of, I mean, I should have let me redraw it. I'm drawing this part so you know it should be kind of like this, right? So let's say this is my wave, a half wave I'm drawing, and if this starting point is, let us say at say pi